Today we're going to be going over the graph of tangent, right? Now tangent and cotangent are very similar, so once you know one, you basically know the other. For tangent, we need to remember the first trig identity that I taught you guys. Do you guys remember what tangent of x or tangent of theta is equal to? Tangent is equal to sine over cosine. So using sine divided by cosine is how we're going to be able to graph tangent. Now let me show you exactly what I mean. If I go ahead and tell you 1, 2, 3, 4, we'll plot this here. This will be pi over 2.
2, 3, 4. This will be pi. 2, 3, 4. This will be 3 pi over 2. 1, 2, 3, 4. This will be 2 pi. Okay.
So if I have this graph right here, this coordinate plane, right? And let's say I want to graph cosine, okay? Cosine at 0 is at 1. At pi over 2 is 0. At pi is negative 1. At 3 pi over 2 is 0. And at, oh, I'm sorry, I don't know why I put that over 2. And at 2 pi is at 1 again, has completed the full cycle. So you have a graph of cosine that looks a little bit something like this. I know that's not perfect, but it'll work. And for sine, you have starting at the origin, sine of 0 is 0, sine of pi over 2. If you're not exactly sure what we're doing here, by the way, think of the unit circle. Okay? And the unit circle has coordinate points at 0, pi over 2, pi, and 3 pi over 2, and then 2 pi. So at 0, we're going to have the coordinate point 1, comma 0, right? So that means that my cosine is 1, which is why we plotted that point, and my sine is 0, which is why we're going to plot this point. At pi over 2, we're going to have 0, comma positive 1.
At pi, this is pi over here, we're going to have negative 1, comma 0. At 3 pi over 2, we're going to have 0, comma negative 1. And then for rotation, we go back to where we started. So once again, this is 2 pi or 0. This is going to be pi over 2. And then this is 3 pi over 2.
So going back to graphing, right? Sine, which is my y value when I'm looking at the coordinates on the unit circle, at 0 is 0. At pi over 2 is what, ladies and gentlemen? 1. So at pi over 2, sine is going to be 1. At pi, what is my sine going to be? 0. At 3 pi over 2, sine is? -1. And at 2 pi? 0. We're back to 0. So once again, we have completed a full cycle, full rotation around the unit circle.
And we end up with something like this. We're not going to need the unit circle anymore, so I'm going to get rid of it. And now we turn our attention back to tangent.
So tangent, for example, let's focus on tangent of 0. So what we would do is we would actually go ahead and figure out, okay, well that's going to be the sine of 0 divided by the cosine of 0. Okay? Now if we go to 0, where x is equal to 0, we have sine, which is in red, and cosine, which is in green. And we need to figure out, okay, well, what's the sine of 0? It's 0. So this is going to be equal to 0 divided by my cosine value, which is what? What's cosine at x equals to 0? 1, right? So this is 1. 0 divided by 1 is just 0. So we actually have 0 for my tangent value. So I can actually go ahead and plot that point right there. That's going to be my tangent value is 0. All right, now we can keep going. Okay, if we have pi over 2, all right, so we're going to say, okay, tangent of pi over 2 is the same thing as the sine of pi over 2 divided by the cosine of pi over 2. And the sine of pi over 2 is what, ladies and gentlemen? Well, sine of pi over 2 is, sine is red, so it's up here. Sine is the red one, so it will be 1. So sine of pi over 2 is 1. And then cosine is the green one, so cosine is going to be what? 0. So now we have 1 divided by 0, which gives me what, ladies and gentlemen? It's actually undefined. This is not possible. You can never divide by 0, so you're going to get an undefined answer. And for that reason, at pi over 2, the graph of tangent actually has an asymptote. And actually, anywhere that cosine is equal to 0, right? Anywhere that cosine is equal to 0, we're going to have to divide by 0 again, which is going to give us undefined again. And so thus, we are going to have another asymptote. Anytime that what? Anytime cosine of x equals 0, tangent of x has an asymptote. Right? So we can actually look at the graph of cosine and notice that, well, look, at 3 pi over 2, guess what? There's going to be another asymptote. Now let's turn our attention to this point right here. This is pi over 4. This right here is, yes, pi over 4. Now at pi over 4, we notice something a little strange happening. Cosine and sine crossed. They basically met up at the same point. So tell me, what is the tangent, what is the tangent of pi over 4? In other words, what is sine of pi over 4 divided by cosine of pi over 4? Now for this, you may need to remember the trick that I taught you guys about the unit circle and figuring out the coordinates. Pi over 4 is the same thing as 45 degrees. What is the coordinate for pi over 4? Do you guys remember? Square root of 2 divided by 2, and it's the same thing, square root of 2 divided by 2. So you have the same thing for your cosine and your sine coordinate. Notice that they actually cross each other. So it's actually going to be the same thing, right? And so whenever they cross each other and they're the exact same point, well, when you divide them, what's gonna be your value? 1. Exactly. So anytime that you see sine and cosine cross, your tangent value has to be 1. So you see how they divided over, they crossed over here as well? Even though they crossed underneath the x-axis, this is technically a negative divided by a negative, right? Here we have negative square root of 2 over 2 divided by negative square root of 2 over 2, which is still going to give me, what's a negative divided by a negative? A positive 1. So over here, even though they crossed at the negative point, at 5 pi over 4, which is what that value is right there, we're still going to have a negative 1. Sorry, a positive 1. What's going to be my value for pi? At pi, sine is 0, cosine is negative 1, so what's my value for pi? In other words, what is 0 divided by negative 1? It's undefined when you divide by 0. But when 0 is on top, your answer is just 0. So anytime cosine is equal to 0, tangent has an asymptote. But anytime sine of x is equal to 0, tangent equals 0 too. So anytime sine is equal to 0, that means tangent also equals 0. So anytime you see sine cross the x-axis, tangent will also be crossing the x-axis. And there is one more set of points that we need to worry about. And that's these points right here at, for example, this is 3 pi over 4. So if you look at your unit circle, at 3 pi over 4, you're going to have, let me give myself a little bit of space here. Sine of 3 pi over 4 divided by cosine of 3 pi over 4. What is the sine of 3 pi over 4? Does anybody know? 3 pi over 4 is this way on the unit circle. And you have an x and a y coordinate. It's actually negative square root of 2 over 2 and a positive square root of 2 over 2. So what happens when you divide a negative or a positive, because this is positive square root of 2 over 2, divided by a negative square root of 2 over 2? Your answer is just going to be negative, right? Negative 1. So notice that we have a couple of these dots going on here. And any time that they're basically opposite of each other, one's positive, one's negative, but they're the same value, then your answer is going to be negative 1. So let me go ahead and just for a second erase the red and the green line so you guys can see what cosine is going to look like. Okay? And here we have the graph of cosine. It's going to look a little bit something like this. And of course, just like sine and cosine, it repeats indefinitely. So it can just keep on going and going and going and going. So now we're actually going to go ahead and go through the notes. So 4.5 showed you how to graph sine and cosine. 4.6 is talking about the graphs of other trigonometric functions, specifically tangents and cotangent. Okay? Now, as we already explained, tangent is equal to sine over cosine, and so for that reason, we're able to graph it based on sine and cosine, right? Now, 0, when my x was 0, tangent was also 0. So we had that point right there, right? At pi over 4, which is right here, you know what, I'm going to write that in black. At pi over 4,
And then this would be 3 pi over 4. And then this would be pi. And then 5 pi over 4. 3 pi over 2. And that's it.
okay, so at pi over 4, what did we have on our graph? Both sine and cosine were equal to each other, so we had what? 1. And then at pi over 2, what did we have? If you guys look back, we had what at pi over 2? What was this? It was an asymptote, right? So at pi over 2, we're going to have an asymptote. Okay? And then at 3 pi over 4, if we look back, what did we have? A negative 1. And then at pi, we went back to 0. 5 pi over 4, we went back to positive 1. And at 3 pi over 2, we had another asymptote. So as you can tell, the pattern repeats and repeats and repeats, and you can keep going as long as you follow the pattern.
So here would be negative 1. Here would be an asymptote.
And so on and so forth. And I want you guys to notice something. That I'm plotting a point here, 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 and then an asymptote. Here, 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 and then an asymptote. And I'm not really worrying so much about the curve of the graph in between. I'm worried about it, yes. I don't want it to be too crazy, but these are very important points. So important, in fact, that we call them important points on the graph. And these occur every how often? Do you guys see? Every pi over 4, right? So you got 1 pi over 4, and then pi over 2 is technically 2 pi over 4, just simplified. So we got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is the same thing as just pi, right? And then 5 pi over 4, 6 pi over 4 simplified is 3 pi over 2, and so on and so forth. So we have these important points called, we have these important points every pi over 4. And that's important for us because they're going to determine what my graph is look like. So first thing that I want to talk to you guys about is those important points. These are the points that you would end up graphing ideally. So it's going to be pi over 4 would be the first one.
Pi over 2 would be the second one. 3 pi over 4 would be the next one. And then pi. And then 5 pi over 4. And then 3 pi over 2.
And you would do the same thing, but on the negative side. And you will notice once again that the pattern repeats. So from 0 is 0, pi over 4 is 1.
Then pi over 2 is undefined. 3 pi over 4 is negative 1, then 0, then 1, then undefined.
The pattern repeats in the opposite direction as well, negative 1. And you are free to go ahead and plot these points. But let's talk a little bit about its domain, its range, and its period. Let's start with the easiest one, its period. How long does it take it to complete a full cycle? So just like sine and cosine, tangent repeats and it follows a pattern. So how long does it take for the pattern to start over? One peak and one valley for sine and cosine. But for tangent, we don't really have peaks and valleys. I mean, this is just kind of like an infinite peak and an infinite valley. So how often, how much does my pattern start over? Every 4 what? Okay, so look, here's what I'm trying to say. You're correct, Mr. Weeks. Every 4 quarters, right? But there's a simpler way to say it. So let's say, okay, we start from asymptote to asymptote. That's easy. So we went from pi over 2 to 3 pi over 2. How much is this length right here? 8 little grid marks, okay. And if this is pi over 2, that means that every grid mark is pi over 8. So how much is 8 pi over 8? Yeah, it's 1 pi. So the period for tangent and cotangent is just going to be pi. How does that differ from sine and cosine? What is the period for sine and cosine? A peak and a valley, but what's the actual amount? It's going to be 2 pi. It does vary depending on whether you have a transformation or not. But for the parent function, sine and cosine, it's 2 pi. And for tangent, it's just pi. And that is one of the biggest differences because most everything else, including the formula for finding phase shift and for finding pi, well, and most everything else is going to be pretty much the same because they're based off of each other. But period is going to be different. Now let's talk about range. What is the range of this equation? How far up does it go and how far down? Yeah, it goes forever all the way up and it goes forever all the way down. It never is going to touch this asymptote, but it will keep going higher and higher and higher as it gets closer to the asymptote. So the range you could write as the range is a set of y's such that y is a real number. Let's talk about the domain now, because domain is probably going to be the most difficult to get. Okay. So if we're talking about domain, and we know that this repeats forever, what might make this difficult if it's just repeating forever to the left and repeating forever to the right? What stops? So each asymptote is included in the domain or is not included in the domain? It is not included in the domain. So we have to say, okay, from negative infinity to positive infinity, except for wherever there's an asymptote. Yeah? So how would you tell somebody uh, where there's an asymptote? Like if you wanted to explain to me, hey, there's an asymptote every half. Okay, so you're saying every half, so pi over 2, there's an asymptote. What about 2 pi over 2? That's technically a half. Okay, well, then what makes it half? Because from here to here, I added 1/2, and here I could add another half, and I could get 3 pi over 2. Does 3 pi over 2 have an asymptote? Every whole after a half. This is a half. This is not a whole. So you're saying every other half, right? So you're adding a half here, but this is not an asymptote, and then you're adding another half here. So what you're trying to tell me is this, that if that basically there's going to be asymptotes at pi over 2, and then anytime you add a full pi to it, because 2 halves is just 1 pi. Pi over 2 plus pi. Now, how many times can I add pi? Just once or two times? Can it be pi over 2 plus pi and pi over 2 plus 2 pi and pi over 2 plus 3 pi's? Yeah, it's going to be infinity pi. So the way we're going to denote that is we're going to say it's going to be at pi over 2 plus n pi, where n is a number, an integer, a variable. What is n? A whole number, right? Because if we make it a fraction, then there's no point in talking about full pies anymore. So what do you call whole numbers, whether positive or negative? Yeah, so where n is an integer. So my domain is going to be a set of x's such that x is a real number except for anytime you take pi over 2 and you add n pi. With the little asterisk that n is an integer. And so that's how we would find domain, and that's how we would write domain. Now, let's say that my asymptotes shift, right? And they're smaller, then you would have to account for that in the domain. And you would just say, okay, well, if it's every pi over 8 plus n integers, or n pi integer, n pi, or something like that. But for now, this is enough. Now, let's go ahead and read this together. It says, when determining the domain, consider the fact that there are undefined values that occur at regular intervals. So we already figured that out. Figure out where the first undefined value is, and then how often these undefined values occur. So that's exactly what we just did right here. Notice that there are still important values, however they occur every pi over 4 radians. So I just talked to you guys about important values. These are values that you're going to plot, because the rest of it, the curve, doesn't matter so much as these points do. That's what I'm going to look for. If your curve is a little bit off, I'm not going to care. But these important values have to be precise. And instead of having relative extrema and intercepts, there are x-intercepts, asymptotes, or points that show the vertical stretch. So x-intercepts, which is going to be this point right here, asymptotes, and these points are going to show you whether there's a vertical stretch or not. If they're at 1, they are not stretched, they are not compressed. But let's say that this point was like at 3. Then you know your graph was stretched vertically. And you can still find these important values by dividing the period by 4. So even in sine and cosine, you can find their important values by dividing by 4. Now let's look at this first example. We're going to go through it relatively quickly.
First of all,
we have to notice that there is no amplitude. So amplitude only applies to sine and cosine. This goes all the way up and all the way down, right? Phase shift. So is there a phase shift here? No, there isn't. So we can cross that off automatically. Is there a vertical shift? No, there's no vertical shift. Important values. Well, we need to come back to that one. And reflection. Is there a reflection here?
Oh, yes, there is negative.
That negative reflects it. But it reflects it where? So yes, there's a reflection, but what kind?
Vertically or horizontally.
So, okay. So remember, whether it's vertical or horizontal, is the inside or outside parentheses? So it's a vertical reflection, which means it's reflected across what? Across the x-axis. Perfect. Okay. So to find important values, it's always your period divided by 4. So we need to find the period. Now, back when we were working with sine and cosine, what was the formula for period? 2 pi over b. Because 2 pi is the period for sine and cosine. What's the period for tangent? Guys, remember, period we looked at over here is going to be pi. So in this case, the formula has changed. And the formula is no longer 2 pi over b, but instead pi over b. And so, ladies and gentlemen, tell me, what is b? It's 2. That theta, guys, is the same thing as an x. So it's not a 0. It's the same thing as if it were an x. Let's see if we can try to get rid of it. You could say it's 2x. It doesn't really matter. That theta and that x, or whether they give you alpha or beta, they all are just standing in place for angles for your x-axis. Okay? So we have 2 pi. Sorry, we have pi over b. And my b in this case is what? So it's just going to be pi over 2. And now the important values can be found by taking pi over 2 and dividing it by 4. What is pi over 2 divided by 4? Well, we take pi over 2 and we multiply by the reciprocal 1/4, which gives me pi over 8. So that means that every single pi over 8, I'm going to have an important value. And it also means that my pattern is going to repeat every pi over 2. So if I know that tangent starts off here, what do you think is going to happen at pi over 2? If the pattern is repeating every pi over 2, then at pi over 2, I'm going to have the same thing that I have at 0, which is going to be an x-intercept. Now, this would be pi over 4, and this would be pi over 8. So what's the pattern for tangent? In other words, I want to know what comes next. What do you guys think comes at pi over 8? If we go back, what is the pattern, guys? It goes 0, then what? Then what? Then, okay, so it follows a pattern. So if my important value is pi over 8, what's going to be my next? After 0 comes 1. Okay, now before you plot it, there's one more thing you have to remember. That this is reflected across the x-axis. So if it would be 1, but it's reflected, then yes, we're going to go all the way down to -1, and that's where we're going to plot our point. Okay? But the pattern will still remain the same. What would happen if I take an asymptote and I reflect it across the x-axis? Is it going to matter? Is it going to change? No, so my asymptote will still be at pi over 4. And then my pattern will once again repeat, except that instead of being at -1, I'm going to start at +1, then 0, and then -1. And then what comes after that? Sorry, I put it in the wrong spot. It should be here. And then the next spot is an asymptote. And then it repeats, 1, 0, -1. I think I drew these too low. My bad. They should be there. And then asymptote again, and then 0 or 1 again. So we're going to have graphs that look like this. And it doesn't matter whether it's on the negative or the positive side. The values will continue repeating and repeating.